as we all know, our mentor for this series is Rohan Saini. So Mr. Rohan Saini is the industry expert. We are very thankful to him that he joined the session. He agreed and accepted our invitation to take all these sessions. We receive a lot of DMs on Instagram, LinkedIn, that about the DSA series from many students, and that would be the great part, like students are loving, and that's our pleasure for that. So quickly, if you are new to this session, I'll just quickly give the introduction of mentor. So Rohan Saini is an industry expert in the data scientist and currently working at CBRE. He has also written a research paper and so a very good, excellent academic background. The best part about him is he is always enthusiast about teaching. Teaching is his, or mentoring is his passion, which is very good quality and which we look for in any mentor. Some students look in any mentor. So we are very happy to host him on this session. So I will not take much time. So Rohan, your stage is yours now, and thank you so much for coming.
Yeah, thank you so much, Nitya, for having me here as well.
Thank you. Just
there's
one
a famous,
quick, just one quick. So we will be having a hiring test live after the session concludes. So I request all of you to stay till end and attempt that hiring test. Anyone can attempt it, but make sure that you can attempt only once. So please make sure that you attempt it very at the first place. Thank you so much. So sorry, Rohan, the stage is
no
yours.
problem, no problem. Can you let me share my screen because I am
yes. So do you have one more account?
Yep. There's a DP over there.
Okay, just yes, now you can just see.
Yeah, I can.
Okay, thank you.
Okay, no problem. So there is a famous quotation given by Dr. Andrew Ng: if you want to master anything, start teaching it. So I'm following the same. Let me share my screen. Let me share my screen. Is it visible, guys? Let me know.
Yes.
Yes, sir. Yes, sir.
Great, great. Okay, so today we will be covering trees, binary tree, binary search tree, and heap as well. So these are the most important topics that are really asked in most of the product-based companies for DSA rounds. So let me start with the session itself. So what is a tree data structure? A tree is a non-linear hierarchical data structure that consists of nodes connected by edges. So what is a non-linear hierarchical data structure? You already know that we have covered array, stack, linked list, queues, and these are linear data structures that stores data sequentially. But what happens is if we want to perform any operation like searching, sorting, or we want to delete or add any new element, we need to traverse through entire array, right? But in binary tree or in trees data structure, we don't need to traverse through entire array. That's why most of the operations are covered in log of n big O notation, right? That's a great thing. In order to perform any operation on linear data structure, the time complexity increases with the increase in data, but it is not acceptable in today's computation world because we need to reduce the size of computation as well. Different tree data structures allow quicker and easily accessible data that it is in a non-linear data structure. That's why. So this is the entire structure of a tree. The topmost point is known as the root, or it is also known as the parent as well, because it is all known as the root node of the tree. These are the edges, these are the siblings, these are the leaf nodes. The last value of an entire tree is known as the leaf node. These are the children as well. This is again my parent, my root node. So this is the entire structure of a tree, right? So there are different types of tree as well. I'm having binary tree, binary search tree, AVL tree, or B tree as well. So let's start with like what are the applications of tree. file ecosystem, files inside the folders that are inside the other folders. So inside your system itself, whenever you are storing different files, those so they form a structure of a tree. Comments on social medias, comments, replies to replica, form a trees. For example, you have tweet something and your tweet has having some comments and they're having some more comments inside it. So you can say nested comments. So they forms entire tree, you can say. Binary search are quicker whether an element is present in a set or not. Of today itself, we will be covering binary search tree as well, which is the most important part of a binary tree. Heap we will be covering today as well, so that we can use a heat sort. A modified version called as tries is used in modern routers and all information. So tries is also a most important part of a tree. Most important databases use tree, which are variants. Compilers use syntax to validate the syntax of every program. So most of the compilers use syntax tree to validate the syntax of every program you write. So it creates a tree which contains different syntax and different errors inside it. The most important question is traversing. How you can traverse through entire tree. Anyone having any idea like how we can traverse through entire tree? Anyone?
Yes,
Different.
hello.
Hello.
Yeah. Tell me.
So
There
there
are
are
different sorting is there.
hello.
Heap sort, mod sort.
Please, only one speak at the same time, please.
So
There
may
are
I?
different sort. Continue.
Yeah.
So there are 4 type of traversal, but there are
Okay.
3 commonly traversal like in order, pre-order, post-order. But the 4th is modest traversal, which traverse the big over constant time.
Great. That's great. Today we will be discussing as well, like how we can traverse the entire tree using these
Yes,
three
yes.
methods.
Yeah.
The second, other one, what was you saying, man? Okay, no problem. Let's start with traversing a tree. Give me. So first one is the pre-order. We start with root, left, right. The second one is the in order. We start with the left node, root, right. And the last one is a post order. We start with the left, then right with root itself. So I believe this particular task is kind of confusing. So let me give you an overview of that. Give me a second. Where is? Please give me a second, guys. Traversing. Okay, let me know if it is visible. Please, everyone. Let me create a tree starting with a root node. I'm having another tree. Value G over here. Some values over here. Some values over here. And some values over here. So you can say, give me a second, let me up this. This can make. So today we will be covering pre-order, in-order, and post-order. Let me see. Over here, I, T, C, not C, E, and over here, H, right? And over here, we can see the different values as well, A. So we'll start with pre-order, in-order, post-order. Pre-order means you are traversing or you are on that particular node only at the first time. In order means you are at the particular node the second time, and the post order means you are on that particular node third time. So how we can create that? Just simply on the leaf nodes, just create these two duplicate nodes. Okay, now I will start traversing from the root node. Okay, so right now I'm on the F part. So it is my first time over here, F. Then I will go on B. It is my first time over B. Then I will go on A. It is my first time over A. Is that making sense? Now I will, let me change the color of this. Give me a second. F. Then I traverse on B. Then I go to A over here. Okay, so this is my first place over here. So I will shift down my second time now. Now, second time I'm over here, so would be my in order. Now I will again jump over here. So this is my third time over here. So this is my post order. So when I'm entering that particular node first time, that would be my pre-order. Second time would be my in order, and third time would be my post order. So right now I'm jumping again over B. So B, on B, this is my second time. Please mute yourself, guys. This is my second time over B.
Sir, your sound is doing echo, sir, repeating multiple times.
Hello. Your voice is not audible. Your mic is mute.
Am I audible now?
Yes, you are audible now.
Okay, okay. Thank you so much. I believe I need to start again, right? I'm so sorry, guys.
Yes, no problem.
Let me roll back this. Okay, so starting from F, so I'm coming on the F part the first time. So that would be my pre-order. Traversing through B, my pre-order. Going through A, my pre-order. Now moving back again to A. So this is my second time coming to A. So this is my in order. Moving again to A, this is my third time. Then again, this is my post order. Going back to B, second time in order. Coming to D, first time pre-order. Coming to C, first time pre-order. Coming back to C, second time in order. Coming back to C, third time post order. Coming to D, second time in order, E first time, pre-order, coming to E again second time, in order, coming to E third time, post order, coming to D third time, post order, coming to B third time, post order, coming to F second time, in order. Now this whole system will keep on continue like this. So you can see when I'm coming to a particular node first time, so it would be my pre-order. When coming to the node second time, it would be my in order, and coming to the node third time, it would be my post order. And I keep on traversing through the entire tree. Let me know if you're having any doubts, so or I need to explain it again. Great, Rajat, great. So this is like, you can even answer this question from like in your from your examination point of view as well. Like how can you traverse through pre-order, in order, or post order? Just simply and every tree you are having, suppose this is your tree, simply put 2 extra nodes at the end so that you can able to traverse. Iqbal, like I haven't muted anyone, like okay. Let me know if we can move forward. Let me guys. In order. So in order means Aprajita, like when you are visiting that particular node second time. Over here, after visiting the A first time, you have traverse again to A again. So that's why I mentioned A in order again. That's why. If you are visiting a particular node second time, that would be in order. If you're visiting a particular node third time, that would be post order. Will that work? Let me know. Let's move forward now. Great. So this is traversing. I've covered pre, post, or in order right now. Let's start. What is a binary tree? So what is a binary tree? A binary tree is a tree structure in which each parent node can have almost 2 children. So you can say this is a binary tree. This is a binary tree, and this is also a binary tree. So each node can have almost 2 children. My parent node, my address of the left child, and my address of the right child. So this makes a complete binary tree. So in Python, how you can create a binary tree, just simply use a class-based operations. Over here, created a new class node. As of now, the left value is none, right value is none, and the value we need to provide in the beginning, like what is the value, just like over here, like what is the value at the parent node. Okay, for traversing, this is a recursive function. So every time when I'm using left, so it will again traverse the pre-order. When I'm going to right, so it will again traverse the pre-order. So this is a recursive function. It is calling it again and again. For in order as well, it is again making a recursive call, and for post order as well, you can create a recursive call over here. So you can see, oh, I created a node over here with left value 2, right value 3. Again, left to left value would be a 4 value. So for traversing pre-order, 1, 2, 4, 3, in order, and post order. Let me ask you a question, guys. So is this a complete binary tree? Let me know in the chat section. Okay. Is it a complete binary tree? Okay. Is it a complete binary tree? Anyone? Yes, it is a binary tree. So the value at the leaf node, if the value is at the left side, so we can say it is a binary tree. The value should not be at the right side. Okay. Now this forms a binary tree. This is not forming a binary tree. Okay. Yeah, it should be equal on the both side, but the insertion happened from the left side. And the property says that it should have almost at most two cells, two parent node. Okay, maximum two. It should not be like equal to two every time. Okay. Let me rub this one. So there is a class preparation over here. So the most important question is calculating the running sum of an entire. Let me explain you the question. Write a function that takes a binary tree and returns a list of its branch sum ordered from leftmost branches to the rightmost branches. Is that making sense? Let me give you an example. Suppose I'm having some values over here, some values over here. Some values over here, some values over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the question is, you need to find the value of all the branch sum. Suppose the solution, the output would be for this 15, 16, 18, 10, and 11. How we are able to do that? First of all, you need to find the sum of this branch. After that, you need to find the sum of this branch. After that, the sum of this branch, and so on. Is that making sense to everyone? Let me know. The question is finding the branch sum of everyone. Great, Prajita. So how are we going to do that? Anyone? So what we are going to do is we are going to create a running sum first of all. Running sum. So the running sum over here is we will be starting with 0. Okay, so running sum over here is 0 plus 1. Great, Arshad. The running sum over this parent node is 0 plus 1. Now 1 would be transferred over here. The running sum would be transferred over here. So the value of the running sum will become 1 plus 2, 1 plus 3 equals to 3 and 4 over here. Now that running sum will come over here, 3 come over here, and 2 plus 3, 4 come over here, 4 come over here. Now the running sum come over here, over here, over here. We will gonna stop in which at the point where we are not having any left node or any right node. Over here, what is happening? We are starting from 0 to calculate the sum. If node is none, return none. The running sum would be node plus value plus running sum value. Right, Akshat? If left node is none and right node is none, just append the particular in this particular list. That's it. Is that making sense? It's just a recursive call. And this is an important question which has been asked, like, what is the running sum of that particular? So you should be aware of that. I'll be sharing this particular PDF file. You can see the particular code itself. Let me rub this. Okay, what is the example of binary tree for easy and quick accessible to data in routing algorithms to implement heap data structure? Okay, Rajat, I will explain again, no problem. So over here, suppose I'm having 1, 2, 3, 4, 5. So we will starting from 0 and the running sum over here is 0 and we will be adding 0 plus 1. After that, this running sum 1 would be carry forward over here and over here as well. So the running sum over here is 4, running sum over here is 3. Now this running sum will carry forward over here 3 and 3. So 4 plus 3 is 7, 5 plus 3 8, and this keep on continuing. We will gonna stop at that point where there is no left point, left node is none, and right point is none. Or you want to explain, you want more clarification on that, please let me know. Yes, Arshad, you are right at this time. So what is heap data structure? Who is having any idea what is heap? Heap data structure is completely binary trees that satisfy the heap property. Any node is always greater than its child node and the key of the root node is the largest among the all the other nodes. So max heap means that the parent node is always larger than its children, right? And this, yeah, it also says like all binary trees satisfy heap. Yep, it is not mandatory. It is a type of binary tree, you can say, Rajat. So because what binary tree says that a particular parent node should have two leaf node, two children nodes. So this particular is going to satisfy that property, right? Because at every node, and you can say this, the particular nodes are only having on the left hand side, not right hand side. So this is a complete binary tree, right? The max heap is the root value is always the topmost, and the min heap says that the root value should be only the minimum of the all this. Let me know if it's making sense. Where's my water bottle? Give me a second, guys. Only 1 minute. Okay. So there are two types of heap data structure: maximum heap and minimum heap. So the how we implement these heap data structures, right? So we implement these heap data structures in the form of arrays, right? In the form of arrays. Let me give you an perfect example. Heap. So let me first create a complete binary tree, then so the values would be over here 50, 40, 45, 30, 20, 35, and 10. First of all, I need to convert this into array, because every time any operation that happens is in the form of array itself when you are working with a heap data structure. So let me create an array. 50, 40, 45, 30, 20, 35, and then 10. And every parent node is following the same structure, like the value at these left and the right nodes is always less than the parent node every time. So this is my first, second, third, fourth, fifth, sixth, seventh. So there is a most important property. 4, 5, 6, 7. There's a most important property of a heap data structure. What is that property? That to find the parent node, just divide the index divided by 2 and take the floor value. That's it. Let me give an example. Suppose you need to find what is a parent node of this 30. Divide 4 by 2, second index. So this is your parent node, 40th. Right? What is the parent node of 10? Divide 7 by 2 and take the floor value, 3. Is that making sense? Let me know if I need to explain this again or no. Palash, so this, yeah, I'll explain again. So this heap data structures follows the same principles, right? The parent node is always greater than the leaf nodes. So over here, 50 is greater than 40 or 45, 40 is greater than 30 or 20, 45 is greater than 35 or 10. So this is a max heap, and the min heap is always the opposite of this. The value at the parent node is always minimum. Let me explain again this, Aprajita. So this is my index value. So I have written this entire in the same form, 50, 40, 45, and in the same. This will be written in the same, just like this. Okay. So suppose you need to find the parent value of 30. This node, like what is the parent value of 30? Simply divide the index by 2. So 40 by 2, 4 by 2 is 2. So that second index, it contains its parent value. Also, you need to take the floor of that particular divisible. Over here, 10, divide 7 by 2, which is 3. So this 45 is the parent of this right node. Is that making sense? Great, Rajat. Okay, so how to find the left child? Left child is given as 2 into I. That's it. Great, Arshad, great. So the left child of this 40 is 2 into I. 2 into 2, which is 4. The left child of this particular is 2 into 3, 3. The left child of 50 is 2 into 1, 40. Is that making sense? Great. Similarly, we can also find the value at the right index, right child. Because index doesn't count over here because the value is starting from the 1 only. Aparajita, that's why. That's the property of heap, you can say. Okay. So what is another property? For the right child, 2 into I plus 1. So what is the right child over here? The first index, 2 into 1 plus 1, third. What is the value at the third? What is the right child of that? 3 into 2 plus 1, 7. Is that making sense? Great. Can we say heap is again a binary tree of a binary tree data structure? It is a type of binary tree data structure, Mohan, because it has different properties, but still it is a binary tree, right? Because it is, we are having the properties of binary tree over here as well. It's just like we have new properties, like the parent node should always be greater than. Great, Arshad. Let me update that again. So suppose you need to remove or you need to insert any element. So how you will gonna insert that element? Anyone having any idea? Because those are the most difficult tasks in terms of heap data structure, like removing any element or inserting any element. Anyone having any idea, please let me know so that we can proceed further. Okay, suppose we want to insert any value I can take, suppose 25, right? Great, Akash. So first of all, that value would be inserted on the bottom left over here, 25. Right? Now we will compare if this 25 is less than 30 or greater than 30. Right now this is less than 30, so we won't be able to swap. Let me change the value. Let me see 40, 35 over here. Okay. So let me insert 35 over here. So we will be comparing whether that 35 is less than or greater than 30. So this is greater than 30. So we will just swap the values. So 35 come over here and 30 comes over here. We will keep on swapping the values. If I'm having any bigger number, suppose I need to insert 60 over here, so 60 would come over here. Now we will swap with 30, we will swap with 40, and we will swap with 50, and we will keep on swapping the numbers. $35 is already there at 6. What will happen to that 35? What you're talking? It will already gonna be replaced. We need to perform another function over there, like if we are going to find a duplicates value or not. But still it will gonna replace over there as well, right? Because right now we are starting from the left hand side. Okay, so this is the major operation of insertion. How we can delete the values? Suppose you want to delete 50, just replace 50 with the topmost minimum value of the left hand side. In this particular situation, suppose I want, let me undo that. I believe everyone is understood about how we can insert the value. Let me explain how we can delete the value. Okay. Suppose I want to delete 50. If the value is smaller than the parent, then the compare it with the right child at the same level. Yeah, we're gonna compare the same as well, right, Nikhil? So let me tell you how we can remove the value. Suppose, because Nikhil, we are not going to compare at the right side because a binary tree just start from the left hand side. That's why. Because if we are going to swap any value from the right hand side, so it won't be having the property of a binary tree. We are going to start with the left hand side only every time. Okay. So suppose I want to delete 50 over here. So what I'm going to do is I'm going to remove this 50 and I'm going to replace with top the minimum value 30. Okay, now suppose 30 is over here. I will gonna compare it with the 40. Right? In that case, I'm gonna swap the positions. So I'm gonna put 40 over here and 30 over here. Now I'm also going to compare at this particular point as well, right? 40 is less than 45. Now I'm going to swap the positions. 45, 40. Now this is a complete heap, right? Simply start comparing the values, swap the values, start, right? In the same way, this particular question has been written over here. See over here, like, first of all, you need to create a class variable of max heap. You need to find, mention that what is the value at the left hand side, what is the value at the front, what is the value at the parent position divided by 2, the left child position to 2, the right child position to 1. How we can swap. So this is the way we can swap the particular value. And over here, just simply you need to create a couple of conditions over here. If the left value is greater than the right, less than the right value, or the same happens, then we're gonna swap. Otherwise, we're gonna swap it with the other side. In the same way, you can easily insert any value. Just check whether it is the this value is greater than the max size, and the heap of the size is keep on increasing. Then you're gonna compare, then swap, then compare, then swap. That's it. Right. So let me explain one more important data structure. Then we can wrap the session. Binary search tree. So binary search tree. Binary search tree is a data structure that quickly allows to maintain a sorted number. The left-hand side is always greater than the root node, and the root node is always less than the right child. This is a binary search tree. The left child is always greater than the root node, and root node is always less than the right child, you can say. I have given some important, like, how we can add values over here. You can go through the code once again. Let me know if you're having any doubt over there. We will be sharing the PDF for the same. Okay, so I believe, Nitya, we can start with the hiring test as well, right? Let me know. Kashish, are you there?
Yes, so we can start with the hiring test, I guess. So Nitya is facing
Right.
some issues. So guys,
Okay.
I will be sharing a
Yes,
link.
yes.
Okay,
I'm
Nitya
audible
is here.
now. Am I audible right now?
Yes,
Yes,
Nitya.
you are.
Okay, just give me 2 minutes. Actually, I'm like, my laptop is hang.
Nitya, should I continue?
Yes, yes, just Yes, you can. But
All right. So guys, I will be sharing a live hiring test in the chat box. You all can tap on that link and start giving the test. The link is there.
Yes, everyone. So I would like to thank you, Mr. Rohan Saini, for having this session. And also, like as I told, I will tell you about my Gurukul. So once after 15 minutes, you all come back. I'll let you know. And all the best for the test. And please do not forget to fill the feedback form so that we can actually reach you. If you cannot give the test right now, so you can just please fill the feedback form so that we can know that what's your interest and what you are looking for in the future. Yes, the link is in the chat section. I'm just pinning the link. So I would like to thank Mr. Rohan Saini also for conducting this whole series of the masterclass with us. And thank you so much, Rohan, for having series with us the whole September month. It would be a lot, like very much interested for all of our students, and we have received a lot of DMs about it. And it's a pleasure to host you. Okay, we will share the link once again in the chat section. So the link is there in chat section, but please do not forget to fill the interest form and join our WhatsApp community so that you can actually get the update of these hiring tests. So for the information, we have one more surprise for all of you. We have some resource kit from IBM. So just mention some say emojis, or if you are there, just give me thumbs up so that I can continue. Yes. Yes, Arshad, you can start. Can we have the link of WhatsApp? Yes, the link of WhatsApp group is in the chat section. We will soon share all the this test link in the WhatsApp group also. But please make sure that you start this test from the laptop because it works on the laptop as well. So please do not start this. There's a link, Rohit, in the chat section. My team would put that link in the chat section. Yeah, sure. Where is bounce? Is it? I don't understand what you are saying. Okay. So anyone from the MyWays team can please put the link in the chat section. Yes, this is the test. Thank you so much, Ali, for putting it for your peers. And I would also request Kashish to please put the WhatsApp group also here. Am I audible to you all? Yes. So soon someone from our team will put the WhatsApp group link in the chat section. So how many guys of you have attempted the test? Yes, you can just start the test. I have a quick intro for the My Gurukul to give to you. So, Sheikh, you can like give the CV after this session. You can give the test. The test link will be open to up to 9 o'clock. So you can give the CV then. in the chat, because CV is something which is compulsory for us to screen. So okay, so I'll put this link, a test link, in the WhatsApp group also, so that students there can give this test. And one more thing I would like to know, so since this is the test of a DSA, I would like the 36 participants which are there to be like excited and to be a part. So we have a very great opportunity of many hiring fields such as Scotland, such as Flutter, and such as React.js, Node.js. So if you are interested in the chat, if you are interested in any of that, please join the fill the interest form. We will soon share those links also with you. Rohit, the link is there in the chat section. Please try to join it, and or we will share you an invite for the WhatsApp group. So guys, we have one thing for you. Like, let me give the introduction of MyGurukul. So MyGurukul is an extended domain of MyWays, where we actually hire tech freshers with our hiring partners. We have 30 plus hiring partners, which includes MNCs and top-notch startups like Fleetx and everything, Fleetx, Paytm Money, and all. So we hello, am I? So can't join WhatsApp. Rohit, please check it. We will share it soon with you. There is a WhatsApp group. Kashir, please help. So anyone, if can help someone to join. Yes, thank you. So we have the hiring partners like Fleetx, Paytm Money, which hire for the tech freshers with us. And what's the process for it? So it is free of cost for all the tech freshers. All you need to do is pass our hiring test, pass our 2-stage interview, pass the employer stage interview, and then you can get a 3 months of ongoing training while you are on the job, and get the stipend and get the full-time job after getting through the hiring process. So if any one of you are interested, just let me know in the interest form. If you are interested, we have the openings for Flutter, Kotlin, React.js, and Node.js. So if please let us know about your interest, so that we can send you the respective test also. So please, so interest form is also in the chat section, the feedback form, where you can also give the feedback and show your interest also for the chat section. And also I would like all of you to put on, if someone can actually put on the LinkedIn and show that yes, they are a part of this DSA sprints. And also please feel free to connect to mentor Mr. Rohan Saini on LinkedIn, and please do not forget to follow MyWays also on LinkedIn. Any other questions? I think now you can attempt the test. The test window will be open by 9 p.m. So please make sure you have attended the test, and please try to attempt it on the desktop. It's a highly recommended. And if you have any question, feel free to ask. And thank you so much for being with us whole series, September series, and be it with us. We are very happy to host you. We are very, very happy that Rohan Saini, Mr. Rohan Saini agreed to coming and conduct this session with MyWays. And also we would love to hear your views over the social media, and very much interested over this. So thank you. I think it's all for today. I hope all of you save these links. This is very important for the test link and the WhatsApp link, because on WhatsApp you can reach out to us always. So thank you so much, and I hope that this session might provide the value, and we would love to hear your feedback. Thank you so much, Rohan. Thank you so much, and happy weekend to all of you. Bye.